Today we are going to be swapping the NL4 as shown here with the new NLC, which will allow us to connect more devices through a single network drop. We will need to make sure the system is powered down. Then we will need to remove the SPI connections and disconnect the power connections along with any additional sensors that may be connected. After all cables are disconnected, we can then start to remove the screws from the standoffs holding the board inside the enclosure and remove the board. Once removed, we will then start to disconnect the SPI cables from the other boards and pull the SPI cables out from the enclosure as they will no longer be used. After all the SPI cables have been removed, we can then start to install the new NLC in the spot the NL4 was located at. And begin to wire it back up, starting with the power connectors. If the cables for the power were disconnected entirely, make sure to reconnect to the power board using the V+ and V terminals below the DC1+ and BR SPADE connection points shown, as this is a designated connection to power the NL devices. Next, we will be connecting the new temp sensor shown here to the NLC, the black lead connecting to the GND, white to the SDA, and red to the 3V3 screw terminals. Then place the sensor under the FPO board. Next, we will be installing the RS mod onto the FPO and M8 boards. Note, newer versions of the M8 and FPO will have these connections pre-installed and will not require the RS mod to be installed. When installing the RS mod, it is suggested to use a pair of needle nose pliers to install the standoffs to make it easier to place them. Once the standoffs are in place, we can then install the RS mod. Insert the pin side first, then once that is landed, make sure the standoffs are lined up with the holes on the RS mod board, and apply pressure to the standoff side of the board until the standoffs snap into position on the RS mod board. Do this for all boards needing the RS mod installed, such as the FPO and M8 boards. Afterwards, we will be using the provided RS485 cables to connect the devices. Each RS mod board has two connections to pass through from board to board. In this video, we use the shorter cable to connect the FPO to the NLC due to the placement of the NLC. Then we use the longer RS485 cable to connect from the FPO to the M8. To connect from the M8 to the SD4, we use one of the shorter RS485 cables and cut the end off of one side to expose the cables. We can then wire the exposed cables into the RS485 screw terminal on the SD4, with the gray lead tying to B, white to A, and exposed wire to GND. After connecting from the M8 to the SD4, make sure to also move the 5-pin connector from SPI to RS485 as shown here. Once moved, you can then also program the dip switches to identify the M8 for when the system powers back up. We will be doing the same for all connected boards. Refer to the NLC manual for the dip switch numbering. If you have a B150 in the system, you can go from the SD4 to the B150 using another of the RS485 cables, with both ends cut following the same wiring pattern of gray to B, white to A, and exposed wire to GND. It can be easier to place all 3 wires into the terminals at the same time, instead of trying to do one at a time. After everything is wired up, you will be able to trace the RS485 from board to board to board like a daisy chain. With everything connected, the system is ready to be powered on and then configured in the NLC provided software.
Thank you for watching. If you want to stay up to date on all our latest products and tutorials, please consider subscribing and see you in the next video.